I just got these little guys here in the mail. These are the B2 Audio RC2s. Look at the stance on this little guy. Amazing. Look at what B2 Audio is hiding under this tape. Look at what they're hiding here. I think it looks better without the sticker. Just to be able to say that I have a 2-inch woofer with a 3-stack magnet on it. Yeah, I'm gonna pump some sounds through it. The Rampage RC2 come packaged in a black and white retail box. And on the back here, it got a pretty interesting tale. Basically, what they're saying is that this 2-inch subwoofer inside of this box is an exact replica of one that's 1/10 its size. Okay, so basically they're saying that there was no shortcuts in this. Let's look at how they have this thing packaged. As you guys can see on the screen, they did a pretty good job. It's no different from their larger subwoofers. You have it being protected in plastic wrapping from the elements. That means, you know, rain, dust, sleet, nothing's gonna get in here to affect it. They have thick foam surrounding all portions of this 2-inch cone. The same thing that you guys seen me demonstrate on the 8-inch variants of this and others. So they didn't skimp out. They actually went into great detail to present this little product. So who is this for? You may ask yourself. Who would want a 2-inch subwoofer? Well, the RC world is huge. It's a multi-billion-dollar industry. And yes, people in the RC world want to make their vehicles look as realistic as possible, and they have been for years inserting or implementing sound systems inside of their vehicles, and this is B2 Audio's attempt at entering that market with the 2-inch subwoofer. I must admit, a very realistic looking subwoofer. This thing has aluminum basket, it has non-pressed paper cone, and it also have direct tensile leads, believe it or not, on a 2-inch subwoofer, which is amazing. I think the image on screen right now speaks for itself. You clearly have a view of the spider. You clearly have a view of the foam surround that they implemented here with branding on the dust cap. Believe it or not, this little thing is just mind-boggling. I don't even see how they have machines small enough to even make this stuff, right? There's another look at the direct leads there to the voice coil. And these are about, I want to say 16 gauge wire that they have on here. 14 to 16 gauge wiring. There's the glue job on the spider and the voice coil assembly. And yeah, this thing is the real deal, guys. Look at this copper coil. This thing is amazing. The only thing that's a bit odd about it is the zip tie that is there, but also the zip tie gives you a feeling of how small this thing is. It fits in the palm of your hand, but man, does it make a big statement. And in case you guys needed a size comparison, this is my NVX 1 1/8 inch dome tweeter right here that I'm doing a review on. This is coming soon, but just look at this. But aside from the height, the diameter of the tweeter is actually bigger than that of the subwoofer that B2 Audio has created. I don't think anyone has done this before on this scale with this much detail. And here's another size comparison with what I had considered the smallest subwoofer I ever had on the channel, which was the CT Sounds Miso 6.5 inch subwoofer. So yes, this is a 6.5 inch subwoofer compared to the 2-inch. And I must say, this little guy makes the 6.5 look big. it looks absolutely massive next to this little bitty subwoofer. And once again, I just had a lot of fun filming this, and I hope you guys as well is enjoying what B2 Audio has created here. Look at the height difference on that. That is so epic to me. Once again, the dust cap on the 6.5 is bigger than the little B2 Audio. And just in case you guys needed another comparison, I just had to just send this one home with the coaxial. Once again, this is from the X series coaxial set by NVX. And look at this. The tweeter on the coaxial is actually around the same diameter as this little subwoofer. Amazing. But enough of that. I have plans to build a real enclosure for this thing, and I want it to be a large enclosure because I know the FS of this thing is around 100 hertz, so I need to bring that down to around 65, 70 hertz, which is going to make it a massive enclosure. And in order to do that, I'm going to be utilizing 4 of these small drivers. So you guys just sit back, grab a cup of coffee, maybe some tea, as we plug the TS parameters into WIISD and get a digital design for an enclosure for this little guy. Then we're going to go on to SketchUp, where we're going to be creating a 3D model of that exact enclosure. And then we're going to use some MDF wood over from Home Depot, and we're going to build an enclosure for this little guy. Later on in the video, as always, is going to be the music test. So this is going to be a pretty long one. Hope you guys stick around to the end. You will not be disappointed. All right, so right now we're over here in WIISD, and as you guys can see right here, I have my transfer function magnitude graph pulled up. This is basically the response of whatever I have calculated for TS parameters of this driver. For all of those who are not familiar with WIISD Pro, WIISD is a piece of software that you can use to create a virtual environment for whatever driver that you are trying to build an enclosure for. In this case, we are using the B2 Audio Rampage RC2, and this is its TS parameters. Its TS parameters look like this. So you come in here and you plug in all the parameters, and then you save this, and later on you can load this into any type of enclosure that you want in terms of sealed, vented, and it also do 4th order and 6th order bandpass as well. It does not do T-line enclosures, and it does not do horn enclosures. In this case, we're just going to do a simple base reflex enclosure or a simple ported enclosure. If you can tell from the number of drivers here, we have 4 that we're going to be implementing in this build, and this is a standard configuration. This is not isobaric or anything of that nature, but you could just click this if you wanted to go there, but we're not. All right, so we're going to come into the box information. Once again, this is a vented enclosure, and this is the volume and tuning frequency for the rear chamber. Rear meaning the rear of the driver. And this is the little icon right here that you can use actually to drag the mouse back and forth, up and down, will manipulate this response curve right here. For instance, if I was to drag this upwards, you see what's going up? The tuning frequency is going up. If I was to drag it this way, the volume is being manipulated. Get where I'm going with this? So let's just reset everything back to where we had it. So this was 300 cubic inches, and our tuning frequency is 75 hertz. Now, I understand that some people are going to look at this and say, well, this little driver has an FS of 95 hertz, so why would you try to tune it in an enclosure this low? Well, I don't want to demo this to you guys like everyone else is demoing it to you in these little bitty enclosures, and it sounds like toys. It looks like a monster, it's small as a toy, but I don't want mine to sound like a toy. I want it to sound like something that is actually reasonably usable. So that's why I'm tuning it to 75 hertz. Now keep in mind, anytime you take a driver with an FS this high and try to tune it to 20 hertz below its FS, you're gonna need to have a pretty big enclosure, okay? So let's look at this. The vents, I'm trying to make it look nice, so I want a dual vented enclosure. So you have two vents. It's gonna be shaped in square or rectangular. And in this case, you put in the vent diameter. In this case, it's gonna be 2.5 inches high, and it's gonna be 0.65 in width. So 0.65 is a correction that I made after I built the box. It was originally 0.5, ½ inch wide, and it was supposed to be 2.5 inches tile, giving it a cone area of 3.2 square inches. 3.25 square inches is a lot for these little bitty drivers, but it's gonna sound nice. If going back to the box, you can see that this box requires a volume of 300 cubic inches, which is huge because you're talking about a driver that is only 2 inches by 2.5 inches. So that's 5 square inches for one driver itself. 5 square inches, and you're gonna need 70. You're gonna need 75 square inches of volume for one little bitty driver that's only 5 square inches. So that's tremendous. You would not want a subwoofer like this in real life for your vehicle because it probably wouldn't fit. Anyway, moving on, we're going to the signal here, and we're gonna tell WIISD Pro that we want to throw 50 watts at this setup. And the reason why this is important is because later on you can look at an SPO graph of it. Why 50 watts? Well, each of the drivers are 10 watts a piece, right? That's the RMS power rating of this subwoofer. So 10 watts times 4 gives you 40 watts. And the amplifier that I'm going to be using has 50 watts per channel. This thing has a max power rating of 40 watts per subwoofer. So I'm guessing 50 watts, a little bit over 10 watts is not going to hurt it. 15 watts per is not going to hurt anything. So that's what I'm going for. And once again, go back to the box, go back to the vents, and go back to the signal, and you're almost good to go here. You do at this point want to check your SPL graph just to see exactly what that would look like. And WIISD right now is guesstimating that this enclosure would have a 103 dB, right at, a little bit about 103.2 is what a 103.3 dB, decibel score is what this would get SPL wise. But this is something that I want to let you guys look at here. If we go back to our transfer function magnitude graph, this is your response curve. Look at the response in between 70 hertz all the way down to, or all the way up to 113 hertz. From 70 hertz to 113 hertz, you only have a 1 dB difference in between the response here. So this is a very flat response from, once again, around 70 hertz all the way to 113 hertz. That's over a 40 hertz spread. This is bandpass response. And the good part about this is that it doesn't immediately drop off like a bandpass enclosure would. It gives you a gradual roll off, like any bass reflex enclosure would do. Just wanted to share that with you guys before we move on in the video. All right, so right now we're over here in SketchUp, and I wanted to share with you guys the plans for the box build here. Right now what you guys are looking at is an overhead view of the cabinet that I plan on building for this setup. You have 2 window braces that are centered, and you also have 2 very long ports here that I kind of wanted to go for a little bit of styling, so I implemented 2 ports for this setup. Right now what you guys are looking at is that same enclosure with blue field. So the blue field actually is representing the internal volume. If you guys can look at it, take a close look, you will see that the port area, or the area that is inside of the port, are not filled in because they are not part of the internal volume. You don't calculate this when you're calculating internal volume. You can also see the spacing for the woofers themselves are actually hollowed out. This is very important when calculating internal volume because you want displacement to be accounted for as well. And this is what you're seeing with this blue field area isolated from the enclosure. The ports have been carved out, and the spacing or displacement for the woofers have also been carved out. In total, this is 300 cubic inches for this setup. a small but relatively large in relation to the size of the drivers. This is a very large enclosure. To be more specific, each of the drivers they only take up 5 cubic inches, but per sub you need 75 cubic inches. So this is massive in relation to the driver. So anyway, what this here is a representation of the cut pieces that I would have to make with measurements in case anyone is planning on building something similar to this. These are the measurements for this setup. So hope you guys have some fun. Whoever decide to go ahead and build them one as well, these are the measurements that you would need to get started. All right, so next up is wood selection. We already have a design. That design calls for a 1/4 inch MDF. So that's exactly what we're gonna do. Headed over to Home Depot and look like we got a 2 foot by 4 foot piece right here for around 14 bucks. Of course, this would be a lot cheaper if I could have gotten a whole sheet, which is 4 by 8 foot, but this is what we're working with, so this is what I grabbed. This is the first cut piece that I made right here. Since the height of this entire enclosure is 2.5 inches, I pretty much made 3 strips of that 4 foot a piece. And that should account for all of the pieces that I'm gonna need from my cut sheet. This is my cut sheet, so once again, if you guys are planning on building this, pause it and take notes. And once you have all your pieces cut, you're left with a flat pack. The flat pack is very satisfying to stack because it gives you a sense of moving on to the next step, which is going to be dry assembly. And here's dry assembly right here. Dry assembly is a process that is very necessary because sometimes during your cutting, you don't actually see some minute mistakes that you may make, and getting everything test fitted or dry fitted will allow you to actually see any little mistakes that you may have made, especially with a design like this where a lot of the pieces are similar in length. So always do a dry assembly before you move on to do anything else. And as you guys can see right here, these are the pieces that I'm going to be cutting out. The baffle actually has 4 different cutouts that are going to be for the subwoofers. In order to mark center, you guys are going to see me use a strategy, and I'm going to share a pro tip with you. Also, the bracing for the internal window braces also have 4 cutouts that are going to be needed for structural integrity. So I'm going to be using a hole saw to do all of this. And for everyone who's watching who may not have all these special tools that I have, I like to actually throw in a few pro tips for everyone that's on a budget. And right now what I'm going to do is I'm going to show you guys how to find center on any cut that you make that requires you to mark a center. All you have to do is use X's. X's always mark center. And in this case, is no different. So what we're going to do, we go corner to corner. We find the center of this piece, and we know we're going to need 4 sections here. So we just keep on going from corner to corner for each individual rectangle or square that we make, and that's going to help you mark your center. And I'm going to do this throughout this build. So just know that you don't always have to have, special tools to do this kind of stuff, or even know how to use a ruler in that to that degree. You can just use very simple geometric shapes and get the desired results. Once you've marked center, what you have to do now is to take that center and put a guide hole there. If you guys notice, the Forstner bits have a very pointed tip in the center of it. That'll be your guide hole. Once it hits this pilot hole that you're finna create right now, you are ensured that that bit won't wander away from the workpiece. Now it's time to cut the holes out. And you have a couple options when it comes to cutting holes. Me, myself, I like to use hole saws, or you can use your second option, which is going to be considered the Forstner bits. Forstner bits are an option because they leave, to me, a lot cleaner of a hole. Sometimes the hole saw will actually burn through the wood, whereas I haven't had that big of a problem with burn through or leaving burns in the wood when I use my Forstner bits. The Forstner bits are originally used for anytime you need to countersink something and leave a flat hole at the bottom of the cut. So this would be good for making dowel holes and pegs and things of that nature inside of wood. But what we're going to be doing is just using it to cut a perfect circle out of our bracing and also for the baffle cutout of the woofers. For those of you who have been on the channel for any amount of time, you probably have seen this guy before. This is a bench drill press that I bought from Harbor Freight quite some time ago, and this thing has been very, very faithful to my projects. Anytime I need to drill a perfectly straight hole, I pull this thing out. It never has failed me. It has 5 different speed settings, but in this case, we're using Forstner bits. And what we're going to be doing is using it on a slow speed, not the slowest speed, but second to the lowest speed. Because when drilling with Forstner bits, you actually want a bit more torque and less speed. So I'm going to go ahead and get this installed, and then we're going to take it outside because I don't want to get my shop dusty. All right, so right now we're outside, and what you guys are looking at is me using that pilot hole that I created to guide the Forstner bit into the workpiece. And I'm gonna do something here that's very important. You don't want to go all the way through the material, and the reason why is because you can get the tear out on the other side. You want a clean cut, and you already have that guide hole there. Wait till the guide pin in the center of the Forstner bit extrude to the other side and flip it over. And what this is gonna do is give you a perfect cut every single time. If you guys can pay attention on screen right now, you will see that we have a perfect hole right there, front and back, perfect hole. Of course, there's a little bit of discrepancy in the center, but that's nothing. Just sand that away if you don't like it. And this is all we're left with right here is this little wood disc. And I'm going to be doing that for the remainder of the bracing and the baffle cutout. Okay, so one thing I want you guys to take note of here is that some of these pieces have been marked on the edges right here, and the reason I marked them is because these are the port pieces, and they're gonna need roundovers. So some of the subwoofer, the enclosure that I have built is gonna be for airflow and for purposes of, to reduce chuffing or port noise. What we're going to be doing here is using some sandpaper to round over the edges of this wood. Now, yeah, I could have broke out the router table and done all that, but sometimes, like I said, in some cases, you just want to show people the simple or more manual method of doing it, because not everyone has a trim router. Not everyone has a router table. So you can just take a piece of sandwood like I'm doing right now for a project this small, and this is actually quicker than pulling out and getting all safetied up with a router table, right? Because you got to take a lot of precautions. But this right here, very simple to do, very quick, and it made short work of the roundover that I needed. And as you guys can tell, I'm like 90% there. All right, so now it's time for the glue up, and I'm gonna start with the external walls here. But these little small clamps really came in handy for a project of this scale. I can't stress enough how important clamping is. Clamping really ensures that your glue actually goes where it's supposed to go and stays there. It also ensures that your wall pieces go exactly where they're supposed to go and stay there. So never enough clamps. Get you some clamps if you don't have any. All right, as it is with every project, sometimes things just don't come out exactly the way you want them to. I'm not too concerned about this, but man, I'm gonna tell y'all, these trim router bits right here are a lifesaver in these type of situations. If you guys are interested in where I got them from Amazon, and I'll leave a link in the description below for you guys to go and check it out. Any tool that you see me using here has a link in the descriptions below. These are affiliate links, and any purchases does help out the channel, so thank you guys in advance. One of the cool things about the RC2s is that they come with a mounting ring. This is a metal mounting ring, and what it does is it secures the woofer to the baffle. Pretty cool for something of this scale to have something such as this. This is usually a premium item to have on a speaker or a subwoofer. So B2 Audio did pretty good when doing this, and what we have to do here is create some pilot holes for the screws that goes there. So you guys see here on the screen what I'm doing. I just put the ring on there, I mark the spots, and then I use the drill bit to actually go ahead and mark those pilot holes. All right, so I wanted to give you guys a interesting contrast in between a single enclosure for one of these little guys and a quad enclosure for 4 of these little guys. Look at this. Look at the size difference. In case you guys are wondering, why is that thing so big? Well, it has an FS of 95 hertz. It's not a subwoofer. It's more of some kind of mid-bass driver or something. Yep, FS 95 hertz. It needs a lot of space in order to do low frequencies. Just for all intents and purposes, to let you guys see what will go into a build like this, this is why I'm doing it. To see the structural element of it, not so much as the performance. You know, you already know if these was 12-inch drivers or 8-inch drivers or whatever, that they would hit the low end very effectively. And this is how you would construct an enclosure with dual ports. That's what it would look like, low profile. And this is what it would look like if you were to do one for a single driver. So we're looking for structural design more so than performance. But there you go, cute little contrast. This is what I'm going to be using in order to connect to the box. So I got a couple of these laying around from an old speaker that I had to tear down, and I'm going to be repurposing them. So these are push terminals, just like that. And they have a screw in on them like this. And I'm just going to be making a pilot hole in the back of this thing and screwing them down. That's how it's going to wire up. All right, so by this point, you guys already know how I always mark for center. I just use that center chamber for a guideline, and these are my 2 spots right here. X marks the spot, right? So I'm just going to be using this little center punch. You know, it's very simple. This here creates a little divot right here. And what that little divot does is it keeps your drill bit from wandering. Let me turn this filter off. I always keep the air filter running when I'm in the shop because you got, you know, you're sanding sometimes, dust kick up and, oh shit, damn near broke my damn finger right there. But anyway, so this thing has a pretty sharp tip on it. And that's what you want. You want to take it and it clicks and it spring loads like a little shock to it, right? And give you 2 divots so that you can go ahead and run your drill saw. And once it goes in there, it stays, right? It won't wander off. Just like that. And you can do the next one the same exact way. Cool, right? And that's what a center punch does. I always used to think these things were useless because, I mean, I always use like a hammer and a nail, but this is quicker, more efficient. All right, so once you made your hole, you just want to, you know, get it going. Get this thing screwed down. Just like that. It should twist. I'm sorry, it's kind of dark. It should twist right on in there, just like that. You see how I'm hand screwing this in there? Because at the end of the day, that's all it is a screw. The whole thing's connected. And if you find yourself having some hard time with it, keeping it straight or whatever, you can always use the holes in it like this. See that hole goes all the way through for the speaker wire? Just stick something in it like this. Let me show you. Stick it in there like that and just use it as a screwdriver, like a handle. And you can just turn it like this. Not with one hand though. So now it's come time for me to find a method to adhering the acrylic top to the actual enclosure. What you guys seeing right here is double-sided foam tape. This foam tape is about 1/16 of an inch in thickness. It's 3/4 inch in width. And I have taken my X-Acto knife here and I have sliced it into 3 sections. So each of these sections is approximately 1/4 inch. Of course, I'm using an MDF material that's 1/4 inch. So this should save me on a whole lot of tape by creating perfect strips for the top walls of the enclosure. Okay, so now comes for the final ohm load wiring of the subwoofer. So I'm trying to get a final impedance load of 4 ohms. And in order to do so, what I am going to be doing is I'm going to be wiring these in series parallel, meaning that I'm going to take the 2 pairs, wire them in series. There'll be 8 apiece, 8 ohms and 8 ohms, and then I will wire them in parallel. And that would bring the final impedance down to 4 ohms. So like I said, series parallel down to 4 ohms. Look at the stance on this little guy. Look at this. Amazing. And guess what I just discovered about this little subwoofer? Look at what B2 Audio is hiding under this tape. I mean, I get it. Marketing is everything, right? So you can self-brand, you know, and no one's gonna get mad at you. But look at underneath this strip of tape here. I'm trying to do this one-handed. I know I may look flicked, but it is what it is. Look at what they're hiding here. I think it looks better without the sticker. just to just to be able to say that I have a 2-inch woofer with a 3-stack magnet on it. That's amazing, man. That is absolutely amazing for them to do this. Look at this little guy. Wow. I'm blown away. This is definitely conversation piece of 2024. That's amazing. Okay, so let's take a look at the mechanical suspension here. I'm blown away by how much movement I can get out of these little bitty cones here. And the reason why this is very important is because before testing, I want to see what their mechanical limit is. I don't want to hurt them. And I also want to give you guys a few shots of what the voice coil and suspension looks like under stress, because playing music is moving too fast for you to see this. And we're going to be sending the sounds from the WIISD Audio Bluetooth amplifier. This amplifier is 100 watts, so that's 50 watts per channel. These things are 10 watts RMS a piece, and they're 40 watts peak a piece. So RMS rating would be 40 watts. That's about what this thing is putting out per channel, and I have it connected to one of the channels. So I should be able to turn this thing all the way up once I get it connected to my laptop. So I'm gonna turn my laptop on Epidemic Sounds, share the name of the track with you guys, and we're gonna jump right off into this. All right, this track is called Back to California. It does have like some hi-hat type bass in it. I just want to see what the kick drums sound like on this track and see what this thing sound like, because that's around the frequency it's tuned to. So here we go, California, Back to California by Donnell Mace. I have the bass turned all the way down, treble turned up. Let's add some bass. All right, so we're gonna go on to the next track here. The next track is gonna be called Stadium Scam. It's one of my favorites, actually. This one's called Love Obstacle by Blue Steel. I kind of like this one. This one got some dynamic beats in it as well. This one's called Put Her in a Mansion by Dama Beats. Dama Beats. Turn her up. Like that. Let me point out something here. I am noticing that some of these woofers are moving a little bit more than others. Don't exactly know what's going on with that. Like this one here is doing a lot of movement, man. This one not so much. And if you push them in, I want to say this one is actually softer to the touch than this. This one seems a little stiffer. And you know, these three kind of the same, but this one's a bit stiff. Don't know what's up with that. Maybe it's something dealing with the spider. I don't know. But anyway, we're gonna move on to one more song and then we're gonna wrap this up. Okay, this one here is called Silver Tears. Silver Tears by an artist named Dream. I love this song. I love that song, man. That's it. I'm gonna call this a wrap. But before I go, I want to let you guys know that there is more to come from these little guys right here. I'm looking at it from an educational standpoint. I can build any type of enclosure using these little guys. Just to demonstrate to you guys like the different type of enclosures that can be built in car audio, size comparisons between the two, because I would try to build them using the TS parameters that came with them so that you would see like what size of an enclosure you would need for a subwoofer such as this. Like if I was to build a folded horn, a rear loaded horn, a front loaded horn for this type of enclosure, what would be the differences between the two? If I was to build a 6th order bandpass versus a 4th order bandpass, what would the differences be in size between those two versus a basic bass reflex enclosure, or what most people call a ported enclosure? That's what I would want to use these little guys for. So let me know in the comment sections below, what enclosure would you like to see me build next using these little bitty speakers right here? I think that they're fun. And I think you guys will get a kick out of what can be created with them educationally is what I'm saying. So leave a comment in the section below. Till next time, I get back with you guys in the next one. Thanks for visiting the channel to help you simplify car audio. It's the Budget Bass here, and I'm out.